In this video, we're going to go over most of all the problems under Practice Exam 1 posted for our Discrete math class. So if you haven't already practiced or at least spent some time thinking about the problems before you watch the video, I encourage you guys to do so before. Okay, so let's go over from starting with problem 1. So for problem 1, we are given the three propositions. P is you have the flu, Q, you missed the final exam, R is you passed the course. Your job is to express each of these following as a sentence in English. So let's start with A. A would read, if P, then Q. So using our given propositions, this would read, if you have the flu, then you missed the final exam. For B, this would read, if Q, then Q. So in English, this would mean if you missed the final exam, then you missed the final exam. For C, the symbol in between these propositions is this for both of this. This is for English word, it stands for the word or. So C would read, you have the flu, or you missed the final exam, or you passed the course. For D and E, I've written it out so I can deliver this accurately. So you would see these two the first and the second inferences are connected by this symbol, which stands for and. This stands for or. So let's go over. So it'll read as either the first case in the first parentheses, or the second case, which you see in the second parentheses. So you would read, it is either the case that if you have the flu, then you do not pass the course, or the case is that if you miss the final exam, then you do not pass the course. Or both, but you don't really have to say this, the part that is both, because the definition of or itself already contains if the first one or the second one or both the cases. Okay, for E, it's pretty much similar. It's either the first case is the first parentheses, or the second case, which is the second parentheses. So you would write either you have the flu and missed the final exam, or you don't miss the final exam and do pass the course. In my previous video, I think I used the squiggly line. That's also the negation. Please note that the symbol that we see in this problem and the textbook and the squiggly line I used in the, I think it was the homework 1 video as well as the homework 2 preview video, they mean the same thing. Okay, so let's go over problem 2. Problem 2 is pretty, the ideas is similar, but you're doing the opposite. Now you're given the P and Q, and your job is to write each of these English expressions using P and Q. So let's start with A. You do not drive over 65 miles per hour. So this would mean that, let's start here, A would be driving over 65 miles per hour is P, but you're just not driving it. Go to B. B states that you drive over 65 miles per hour. So that's just P, so let me start by writing that. But you do not get a speeding ticket. So getting a speeding ticket is that, but you don't get it. So now what do we put here? If you think about the sentence for a bit, you are driving over 65 miles per hour. At the same time, you're not getting a speed ticket. So this would be connected with the and statement. Okay, so let's do C. C states that you will get a speeding ticket if you drive over 65 miles per hour. So you would do, this is if P, then Q. All right. Do D. D states that if you do not drive over 65 miles per hour, then you will not get a speeding ticket. So this is another inference question. So if you're not driving that speed, then you're not going to get a ticket. Keep doing that. All right, lastly, driving over 65 miles per hour is sufficient for getting a speeding ticket. So this is another fancy word, but this just means that if you drive over 65 miles per hour, then you're going to get a speeding ticket. Okay, so again, C and D are speaking of the same thing. They mean the same thing, but just because in our language, it is stated a little differently. All right, problem 3. State the converse, contrapositive, and inverse for the following sentence. If it snows tonight, then I will stay home. So let's start with the converse. So this given sentence is if P, then Q. My P would be snows tonight, and Q would be I will stay home. So converse would be if Q, then P. So I would read this as if I stay home, then it snows tonight, or it will snow tonight. All right, so now let's go over to the inverse. In our textbook and homework, you will see our inverse is if not P, then not Q. So in English, this would mean if it does not snow tonight, then I will not stay home. Contrapositive. It would be, this is if not Q, then not P. So in English, our sentence would read as, if I don't stay home, then it is not snowing tonight. Or anything that sounds something equivalent to that. I will leave this part explaining why contrapositive is equivalent to the original statement part. It's in the previous video that I made for you guys. It's either the homework preview or the notes on the homework one. Also, if you guys can find this answer to this question in our textbook. Okay. All right, now let's go over problem 4. Construct a truth table for the following statements. So you're given PQR. So I'm going to continue my truth table, and I'm going to start with P, Q, and R. All right, so as you guys know, if it's 3 variables, then I'm going to start making my table with all the different possibilities. So start by doing 4 T's and 4 F's for the first statement. For the second statement, do 2 T's, 2 F's, and alternate doing that. And for the last statement, write all the T and F just alternating one time. Okay, so and if you do this, as long as you follow this, you will be able to make all the possible cases. All right, so we have that taken care of. Let's start. For A, we need P or Q. So let me start by doing that, P or Q. That's going to be our next column. And you guys can also read about this in the textbook. If it's or, then as long as one of them is true, then it's going to hold a true value. And if it's and, then it's going to hold true only if and only if when both values are true. I'm sorry, I think I said or. This is and. Okay, so this is and this is or. Okay, so let's do P and Q. So T and T. So that's going to be true. Again, to truth, so that's going to give us true value. T and F, for and, both of them has to be true to get us to true value. So since this is true and false, this is going to give us a false, and likewise, that's false. And you guys can see that's the same thing, false, false, and of course, if both are going to be falses, then we have both false cases. And this is because if you guys think about the simple statement, if the instruction is that you have to bring pen and pencil to take the test, then you have to satisfy both cases. You have to bring a pen and you have to bring a pencil to take the test. If you bring only one of them, then you cannot take the test. If you don't bring any of them, of course, then you will not be able to take the test. Okay, now we need to do, before we do the whole thing, we need to find what the R is. So negation of R. Negation part is just going to be all of this negated. So true will become false, T, and so on. All right, and lastly, I think we can conjoin those parts. So P and Q is combined with OR. Okay, so now we're looking at these two columns, and these two are connected by OR. And if you remember, if it's OR, if one of them is satisfied, then it's going to be true. So since true and F here, that's true. Both are true, so this is good. Both are false. This is the case that it's going to be false. And this is true, false, true, false, true. And that's it. This is going to be your answer for A. Okay. Now for part B, I'm going to continue to use this table, but I'll write this in color red. So let me do P, if P then Q. So if it's an inference, all right, so if true then true, that is a true statement. And again, we have the same thing, so that's going to be true. If true, then false. If our conclusion ended up being false, then it doesn't really matter what our hypothesis is. If our conclusion is false, then that's a false statement. Okay. Our hypothesis, we may be starting with false statements, but if we're ending with a true statement, if that was our conclusion, then this entire statement becomes true. And this is also true if we're starting with the false statement, then it's expected that we end up with the false conclusion. So overall, those two statements are going to be false. I explained to you guys in the last video. Also, if you guys read the textbook, you will understand why this is. All right, before I do this, I would need to find what this is. So to do that, I would need to find the negation of P, because I don't have a column for that. And it's just the negated part of what we have. So that's false, and the last 4 is going to be true. Okay, now I think we can do if not P, then R. So I'm looking at this column and our third column. So let's think about this. If false, then true. So we're looking at the first row. Then if our conclusion is true, we know that that's going to be a true value. If false, then false. Right? So this is going to be a true statement, because if we're starting as a false, then it's expected that we also end with the false. If false, then true. So this is going to be true because our conclusion is true, and also true because we have both F's. And this is true for both having T's, and if true, then false. So this is going to be a false statement. All right, and we keep going. So this is going to be true, and lastly, false. All right, so we have one more step. This is going to be our last one here. So to do that, we're looking at this column and this one, and they're combined by OR. So as long as one of them has a true value, it's going to take on that true value. So everything is going to be true. It looks like everything is going to be true. All right, so there you go. This column, this is the answer for part B. All right, I'll do the last question in a separate video.